Here we have a dataset of just over 1,000 compounds for which we have measured target affinity data. We have also used StarDrop to predict a range of ADME and physicochemical properties. We'd like to find out which compounds have the best overall balance of these. With StarDrop scoring, we can use one of the example profiles as a basis and then add to this the target affinity property. We will set the importance of this property to be greater than everything else, and we'll say that ideally we would like a pKi of greater than 7. When we click the Go button, StarDrop will very quickly calculate a score for every compound in the dataset. The score indicates the compound's likelihood of meeting the profile that we have defined. The histogram gives an indication of the individual contribution of each of the properties to the overall score. From this, we can very quickly see whether or not there are any properties with which we might have problems. Using the Visualization tab, we can get a very quick overview of how well the dataset has scored as a whole. So in this histogram, we can see the proportion of compounds that met the criteria that we set up for each of the individual properties. We can see from this, for the dataset as a whole, that we may have problems with hERG inhibition. We can also look at a snake plot. The snake plot lists the compounds along the x-axis, ordered from highest scores down to lowest scores. On the y-axis, we can see the actual compound scores. Around each of these is an error bar, indicating the confidence we can have in the score on the basis of the uncertainty in the data that we used. From this snake plot, we can very quickly see that it's only the top few compounds that we can say with any confidence are significantly better than the majority of the rest of the compounds in the set.